Hello, this is Sean from Tech Train Solutions. Here with Basic Electrical 102, Ampacity and Current. You ever wonder why some wires in your home are fine? You have no issues. Your house is great. There's nothing going on. Well, it may be due to because someone rated the ampacity of your house and the wires correctly. And you heard stories on the news, a house being burned to the crisp all the way down to the floor. And you hear later on that it was electrical fire. Well, it may be due to the fact that the ampacity wasn't rated right. So today, we're going to break down the difference between current and ampacity. There is a difference. So why do we need to know about ampacity? And why does it matter? Well, here you go. Fires, right? If you don't understand ampacity very well, you may undersize a wire, which I've seen it before, that the installation over time gets brittle. Might not happen right away, maybe years, but it starts getting brittle. The insulation will break off and touch a ground or neutral, causing a dead short, sometimes a fire, if it's near something that's flammable, right? So this is very important to understand the difference between ampacity and current. So that's why it matters, man. You don't want to have the major fire in your house. You don't want that to happen. So let's continue. Current flow. Current flow is basic simple. The flow of electrons through a conductor. This is a visual interpretation that I'm showing you. If you look to the left, is a toaster, right? This toaster is rated 10 amps total, but we're only going to use one side. So what happens when you use only one side? You only get 5 amps flowing through the toaster. That 5 amps will always be active until the toaster turns off. That is a heating element inside that gives you a nice crisp toast flowing 5 amps continuously. But if you look to the right, that is electrons flowing through that circuit. It is 1 amp is equal to 6.24 quintillion electrons per second. And that toaster is running per second. 5 amps. If you times that by 6.24, it's a lot. I'm not doing the math. You can do it for yourself if you want. So just understanding that, it only takes 0.4 milliamps to stop your heart. So imagine you're working on something like this, a heating element. This is 2.08 amps of electricity, of amps flowing through that heating element. If for some reason you break that circuit and you become part of that circuit flowing through you, 2.0 amp is enough to fry you. I've seen it. I did a hot dog tester at the Scouts. I was cooking a hot dog through. It wasn't much amps, and it was starting to slowly fry it. Luckily, it was on GFCI, so as long as the hot and neutrals in between the hot dog, it started cooking it slowly. And it wouldn't trip until I touched it because I took away the amperage from the neutral. The GFCI senses anything below 4 milliamps and it trips it, keeping you safe from possible death. That's why GFCIs are very important to have in a house. And also arc fault breakers, very important to have in the house. GFCIs will save your life. Arc fault breakers will stop fires from happening in bedrooms. So if current flow is the flow, then ampacity is the safeguard. It is what's keeping you safe. If you follow the rules and everything's perfect, you should not have a fire. It will limit the fire in your house. Now, I have a story. My mom was complaining about outlets in her house not working and working sometimes. And back in the day, I worked for a non-union contractor. I didn't know any rules properly. And outlets in the back have stabs. And I put the wires in the stabs, thinking it's okay. Wire in, out. So all the amps in that circuit is going through the outlet. And she was complaining about the outlets not working or working sometimes. Well, I'm going to pull out the outlet. It literally broke apart in my hands. The screw stayed on there, broke apart in my hands because the heat from the ampacity going through the outlet was so hot. That little piece of metal that's in those little holes was barely touching it, and over time was starting to slowly build heat. And as it builds heat, it builds resistance because it's building carbon on that piece of metal. And if it's got resistance, that's more amps going to flow through because it wants whatever amps that load wants, it's going to get it. So it's going to flow. So now it's a series circuit between the outlet that's going through the carbon or the resistance through your device. And it's building heat, made the outlet completely dissolve and fall apart in my hand. Needless to say, that was 26 years ago when I did that. And I went around and redid all the outlets. What I do now is I put two wires and I wire nut and wire coming out. I do tails, as it's called. I was lucky my mom's house didn't burn down because of me. So let's talk about ampacity. Ooh, there we go. Ampacity. What is it? Well, it's right there. Maximum amount of current a conductor or device can carry continuously without temperature rating. Most wires, if you look at the code, NEC, it tells you to derate by 80%. You got to downgrade the wire. You can't use the maximum percentage of it. Whatever the code says, you got to downgrade it by 80%. That is the rule of NEC. You cannot use 100% of the rating of that wire because it means you're using it continuously over time, and it's rated, whatever the number it is, it's rated because it's been tested at that rating. And over time, they said, hey, let's say 12 wire, at 20 amps, at continuous use, slowly the insulation will degrade at whatever time frame they find. But what happens is the insulation gets brittle. If you use it over the capacity, it gets brittle and it falls apart. And if it's touching a ground or neutral, that insulation breaks, and now it causes a dead short and possible fire or possible death. Because if someone's sleeping, the fire happens when they're sleeping. It's sometimes hard to hear that arc when you're sleeping too, but the next thing else is burning down. So that's ampacity. So what are the factors of ampacity? The factors are, number one, conductor material, copper versus aluminum. Copper can handle more current flow than aluminum. And aluminum is special. You have to treat that a certain way. I know in the state of Delaware and some houses in Pennsylvania, they have aluminum wiring. You got to use special devices. You can't just use any device. You got to use a device that's rated for it. Very important, the material. Next is insulation type and temperature rating. Insulation type, it's made to handle a certain degree of heat, along with temperature rating. You have 60 degrees, 70 degrees, 90 degrees, and higher. Those are factors. Next you have is your ambient temperature. How much of the ambient temperature in a wire can handle? In industry, we use called XHHX in industrial where I work, because the burners near the process is over 900 degrees, and wires near it, even though it won't be 900 degrees, it's still over 180. So those wires got to be able to handle that temperature. So there's insulation's meant for it. Another thing is your insulation conditions. If it's on the roof, you have all the wires round on the roof, and that heat's going down on that wire. That adds to it. It doesn't help, it adds. You don't want heat. Heat's what breaks down that insulation. So that's that versus by inside a house or inside a building, in a wall, where the temperature control is nice, that wire should be able to handle more ampacity than the one on the roof. Roof should be rated right. And another factor, believe it or not, is how many wires you have in a conductor or some kind of underground, whatever. How many wires do you have in there? Because if you have too many wires together, that adds heat. That's why in the code it says you're only allowed so much. It's called pipe fill. What's pipe fill? So make sure you read it, because you don't want all that wire in there causing that heat, causing a possible short later on. And you don't want that, because there's no way for that wire to dissipate that heat. That's why it's very important to understand these conditions. So material, insulation type, temperature rating, ambient temperature, and installation conditions. They are what you need to understand before you run the wire. So here is just an example of amps running through the circuit, ampacity. If you have too much, you'll cause a short, the insulation breaking down. So let's see what happens when you don't size it accordingly. Let's take a look. See what happens if you ignore the ampacity. That was a overload that started, not overloaded, the wires over time. Insulation failed, shorted out, arced, caused a fire, and my nice Christmas tree has burned down my house because of bad protection choices or bad wiring. Depends, because sometimes protection choices, what that means is that I use 14 wire with a 20 amp circuit breaker, or I use 12 wire with a 30 amp circuit breaker. That bad choice, or I wired up wrong. So like, for example, with my parents, when I wired up the stabs in the back and the current was going through it, right? They use heaters in that spot, by the way. That's why. So the the hot was up here, or where the ungrounded conductor started, where the source was. And they plugged in the bottom, so that would go down through the outlet. And it was a heater that was rated 10 amps. And that's ultimately what caused it, because of bad installation on my part. I was from union, just starting to learn. No one really taught me. I was teaching myself. Now much better than that now. So that's why it matters. You got to make sure that you follow the code, you install it properly to be safe and to protect property and yourself. Bottom line, if you don't follow the rules and don't apply them accordingly, you can seriously get injured or, I hate to say it, death. You don't want that. Know the rules. Example, if you're running a wire 150 to 200 feet from your house to a shed, there's things you must consider, right? You got to understand the ampacity of that, right? Because you're running in conduit. What size conduit you're running, how many wires you're running, what type of wire you're running. And I hate to say it, which I'll cover later, it's called resistance. 150 feet to 200 feet will add a lot of resistance, which means your voltage will go down, which means you have more amps flowing through that circuit. You're just asking for trouble. That's what I'm saying. Make sure you follow the rules. Take away what I'm telling you. Follow the rules, follow NEC. If you don't know, ask. It's going to lead to installation failure, a dead short, possible failures, possible death, just from not following the rules. So this is NEC section 310. If you want to look it up, look at the proper wire sizing. If you look at here to the bottom left, it's 14 and 12 wire. That's the two we mainly use in our houses. 14 wire and 12 wire. 14 wire says type UF and TW, they're kind of in the ground, 15 amps for a 14 wire. Now, higher sizes says 20 and 25. That's, you got to understand, all the way up top doesn't tell you what this is for. It could be open air, it could be anything, we don't know. I'm just showing you this is what you look for. So look up top, you'll see it says what it's for. Then you look down here, look at your amperage. Remember, you only can use 80% of this. And make sure you install it right. Make sure you have enough room in your pipe. You don't want overheating, because it can lead to possible injury or death. Use these tables along with environmental factors, sizing, conduit, fill. Use those. Take away that current flow. Again, it's the flow of electrons through a wire. The ampacity is important, because current carrying wires, along with temperature and other factors like conductor material, insulation, temperature, conditions, overheating, damage can cause fire or death. So if you have found this useful, share this episode with a colleague or apprentice. For visuals, check out my overload and short slides in today's deck and the Basic Electrical 102 course that I'm building. So if you need questions, contact Sean from Tech Train Solutions, here to help you become a better electrician, homeowner, if you're trying to do your own thing, or contractor or engineer. So I'm here for you. Thank you. Have a good day.